numbers 1 and 3. There will be a separate video for those if you want to see them worked out step by step, or I'll post the completed notes with all 4 of these. You can look at them all, but I'm just going to do 2 and 4 with y'all right now. Okay. So we have Desmos pulled up, and we're going to first start by inputting. Well, actually, let's read first. Okay, so the teacher wants to know the number of absences a student has affects the test scores. Okay, so this is the data, the number of absences versus their test scores. And the data was used to predict the test score if there were 14 absences. Okay, and the prediction is 60. We want to just be able to state whether that prediction is correct or not, and why or why not. Okay. So we're going to start by inputting the data in Desmos like we were doing the past couple days. So remember that process again is add table, and then we enter our data. So the number of absences is our X, and the test score is our Y. And we put, what do we put here in this line? After we've got the data table entered, how do we do the regression? How do we come up with the equation? Our test is Wednesday. We've got to know this process. I'm going to type Y1, and then the little squiggly, the tilde, MX1 plus B. Very good. Okay, so I'm going to type that in, and it's going to generate these statistics and parameters for me. Okay, so I'm going to take a snapshot of that to put on my notes page. This is what I got, and I'm going to bring it over here. Bless you. Yeah. And is it? That's number 3. Here it is. All right, so this is what I got from that data. Now, they say that they made a prediction that if there's 14 absences, the test grade would be a 60. So we're going to use what we found by doing the regression steps to find our own prediction and compare. Okay, so I am looking at M and B, and I'm going to plug those in to write my equation. So remember my equation, -3 point, and we're going to go to thousandths. The further out you take your decimal, the more accurate your prediction is going to be. So in this one, they didn't tell us specifically what to round to, so I'm just going to go to thousandths. Okay, so that's my MX plus, and then my B is 104.684. Okay, and again, they are asking us to predict when there's 14 absences, so they're asking us to plug that 14 in for X. Okay, so when I calculate that, we're going to go back to Desmos and see what we get when we plug that in. All right, so negative 3.316, multiplying by 14 absences, plus 104.684. And there we get a 58.26. Bless you. Bless you. So the question is, was their prediction correct or not? Their prediction was a 60. We got 58. If we're rounding, that would round to 58, right? So the answer is no. Okay. And because when we used the regression model, or regression equation, we get 58 as the test score. Or 14 absences. Okay, so if you take a look at the data table, we might be able to look at why they guessed 60, why they predicted 60, because 14 is halfway between 12 and 16, right? And so it looks like maybe they were trying to guess about halfway between 51 and 68. But remember, the data is not a perfect line. It's not all the same constant rate of change. So you can't make your predictions just looking at the table and guessing, because yours will be slightly off from actually using the regression model, which is the line of best fit. Do y'all see that? So this is really to point out that you can't just use the table to make your predictions. You've got to do the regression steps in your calculator, or your predictions will be off a little bit. I mean, it's not like it was way off. They said 60 and it was 58, but when you're putting your answer in on a test, that's going to be wrong if you say 60. Does everybody understand that? So we have to do the regression steps in the table, or in the calculator. And look here, this R squared, we talked about yesterday how R squared tells us whether this was a good fit, this equation. The closer R squared is to 1, the better the fit. 0.9361, that's pretty close to 1. So this regression model, this equation that we came up with, it's a pretty good fit. It's going to make good predictions. Y'all feel okay about that? All right, now, if you got to some questions on the day 2, the part 2 practice in Delta Math, the comparing ones, and maybe you weren't sure what to do, it's because we hadn't done an example of comparing yet. So I'm going to do this example 4 with y'all. We're comparing 2 data sets. Okay, and then when we finish this, you're going to have time to go back and complete those Delta Maths if you have not yet. Okay, and some of those questions will make more sense once we do this example. So this says that you have a budget of $100,000 to invest in enhancing employee training for your company. 2 training providers, provider X and provider Y, have presented you with data on the potential improvements in employee performance based on the amount of training purchased. Okay, so we can see we've got providers X data and provider Y's data. For both of these, our X, our input, is the annual advertising in thousands, and then the annual profits in thousands. Okay, so the question down here is, if you spend $100,000 on advertising, which company will provide you with the greatest profit? Okay, so we're going to compare the two. So we're going to write our equation, our regression model for both of these. Now be sure you clear out your calculator from the previous problem. You want to clear it all out, okay, and then start fresh. Okay, so we're going to make a new table. Now we'll do some color coding here. We'll say provider Y. We'll highlight everything from provider Y in pink, purple, whatever that is. And let's do provider X yellow. Okay, so I'm going to start with provider X's data. Okay, so we're going to do our X values. Our inputs is the advertising amount. That's our independent variable. So that's 21. Now remember, these are thousands, but we're just using these to have smaller numbers in our equations. 30,000 and 32,000. For profits of 63,000, 57,000, 85,000, 96,000, and 111,000. Okay, so I'm going to type in y1 tilde mx1 plus b. And I'm going to get this info, and this represents provider X. I'm going to put this next to my data. Okay, so this is provider X. Okay, and now we're going to do the same thing and get provider Y's data entered. So I'm going to clear this out, start fresh. We've got 10, 14, 24, 35, and 43. And then we've got 31, 24, 56, 67, and 79. Y1 tilde mx1 plus b. All right, so now let me grab that data or that information. Use that. All right, so I'm going to write my equation for provider X first. Okay, so I'm looking at this information over here from provider X. So my equation, remember, I'm looking at the M and the B down here. So Y equals 4.193x minus 26.618. Okay, and they're asking us to make the prediction when you're investing 100 grand on advertising. Now, should I plug in 100 grand with all those zeros, or what should I be plugging in? In advertising. Look at our tables. Advertising, do any of these have the thousands on them? No, they're just notated that it's in thousands. So I'm not actually going to plug in 100,000. I'm going to plug in 100. Okay, so they're wanting me to plug in 100 for X. Okay, so when I plug in 100, nope, not there. So I'm going to come back to Desmos, my calculator, clear everything out. All right, so 4.193 times 100 minus 26.618. Okay, so this is the value we get. I'll pull it up in just a second. I'm going to go ahead and do provider B's so we can have them on the same screen to compare. All right, so for provider Y, I'm looking at this M and B. I'm going to write my equation. 1.629x plus 10.350. And again, I'm plugging in that 100 in the same spot. Just keep accidentally clicking on this. Sorry. Okay, so I got my equation and I'm plugging in the 100 for X, just like I did up here. Okay, but now I'm going to see what I get for this equation, because we want to see which one is going to provide the biggest profit. Okay, so it's 1.629 times 100. This time it's plus 10.350. So looking at that, which provider provides the larger profit when I'm comparing this? Provider X on top and provider Y on bottom. Color code that again. So provider Y was the pink one. Provider X is this one. Yeah, that one in yellow is a much larger number, isn't it? Okay, and now this is in thousands, okay? So provider X, and remember it's in thousands, so this is $392,682. Okay, so provider X provides the largest profit. Now the second question off of that says, how much and again, that's a typo, greater. How much greater will the profit be compared to the other company? So what am I going to do to figure out they're asking how much greater? They're asking for the difference. So what math do? I subtract. So I'm going to take the 392,682 minus, and then this would be 173,250. And I'm going to subtract. I'm going to find the difference in provider X's profit and provider Y's profit. And that comes out to 21,000, or sorry, missing a place value there, 219,432. So if we chose to go with provider X, we could make over 200 grand more profit. Easy choice. So do you understand how you do comparisons with the regression models? So you can compare two sets of data and figure out which one is the way to go. Good? Okay. So you have the rest of the time. I'm going to show you a couple of things. Full screen here. In your Delta math, you should see 2 linear regression loaded here. So you've got the one from Wednesday and the one from yesterday. The one from yesterday has yesterday and today's date because we're doing it over 2 days. Okay, so you've got 2 linear regression assignments. This one on day 2 does have some down here on making predictions on 2 companies. These are like comparison questions. Okay, so if you have not finished one of these, you have today, the rest of class, to work on finishing your regressions practice. Now, those of you who finished, you worked ahead, you finished it all yesterday, you have nothing under the past due or upcoming tab. These would both be blank. Nothing here, it's all under complete. I'm going to go and activate our review if you would like to get a head start on the review. When we come back next week, I'll show you the calendar again. When we come back after we have a 3-day weekend. Okay, today is linear regression and making predictions. You have Monday off. We're going to have a review day, and then our test is Wednesday. So Tuesday is a day you get that day to work on your review, yes. But if you start on your review this weekend or today, you can come Tuesday knowing what questions you have, okay? And make sure you get all of your questions answered. If you don't even start the review till Tuesday, yeah, that's fine. The review's not due until Wednesday, You can do it in one day. You'll probably not be able to finish all of it in class. You may have to do a little bit for homework Tuesday night. But the thing is, you may not know what questions you have until you attempt them. And then you'll kind of be SOL because you'll come in and we're taking the test and we don't have time to answer questions Wednesday. Okay, so it'd be ideal to come ready with what questions you need help on Tuesday. So I'm going to go and activate the review. So if you are all caught up, or when you finish your Delta Math assignments today or this weekend, go ahead and take a look at that review, get started a little bit. I'm not saying you have to complete it all, but go ahead and try some of the problems, okay? Any questions about what you're doing? The review, when I say I'm going to go activate the review, it is in Aware. It's the same place where we take our tests. So I don't think I have the icon that y'all have. Mine says Eduphoria. Y'all's is the one that looks like the eyeball and says like student testing or something. That's where you're going for the review. Okay. So, and I'll put that here. I'll add that to review. I'll put in Aware, or I'll put the picture of the icon or something so you know where to go look. But I'll go activate that now. So you're doing Delta Math. If done with Delta Math, you're going to be able to start your review.